Let's learn about the future technologies. Let's learn about the future. Welcome to Hyperfocused Engineer.
Picture a student cramming for a test, but they don't actually learn anything. They just memorize the practice test, every question, every answer, word for word. Question 3 is B. Question 7 is the mitochondria. They can recite the whole thing backwards. Practice day comes and they ace it. Perfect score. They feel like a genius. Then the real exam lands on the desk, and the questions are all different. Same topic, new wording. And they freeze. They crash. Because they never understood anything, they just memorized. Here's the wild part. Machines do the exact same thing. It's called overfitting, and it's one of the most important words in all of machine learning. Overfitting is when a model memorizes the training examples instead of learning the general pattern. Remember the very first idea in this series. The whole point of machine learning was predicting new, unseen things, the spam email you haven't gotten yet, the house price you don't know. A model that only aces the examples it already saw is useless. That's not learning, that's memorizing. Open the notebook, cream graph paper, pencil in hand. Same house price dots we've been using, size across the bottom, price up the side, dots climbing bottom left to top right. When we learned how training works, we drew one clean line through the trend. Simple, honest, but those dots are real data, and you already know real data is messy. It's got noise, little random wobbles that don't mean anything. Now watch what an overfitting model does. Instead of a smooth line, it draws a crazy wiggly curve, one that bends and snakes to touch every single dot exactly, noise and all. Two lines on the same page. The clean, straightish line that follows the trend but misses a few dots slightly. And the wild wiggle that hits every dot perfectly, a squiggle that loops up and down through all of them. On the training dots, the wiggle looks like a winner. Zero error. Flawless. Now a brand new dot appears on the page, a house the machine has never seen. The clean line. It predicts it beautifully, right where it should be. The wiggle. It shoots off to some insane, wrong value nowhere near the truth. Perfect on the old dots, useless on the new one. That's overfitting. The goal was never to be right about houses you already know the price of. You already know those. The goal is to be right about the one you haven't seen. A model that memorizes scores perfect on data it's seen and falls apart on anything new. Simple line, a little wrong on the old dots but right on the future. Wiggly line, perfect on the past, lost in the future. You want the line that generalizes. So how do you catch the cheat? A train/test split. Before the machine learns, you hide some of your dots. Put them in a drawer. The model never sees them while it studies. Then, after it's done, you pull them out and test it on those held-out dots. It's the oldest rule in teaching. You don't grade a student on the exact questions they studied. If the model nailed the training dots but bombs the hidden ones, you caught it red-handed. It memorized. There are gentler fixes too, and they're common sense. 1. Keep the model simpler. Don't let it draw wiggles in the first place, force it toward that clean line. 2. Get more data. The more real dots you have, the harder it is to memorize them all, and the more the true pattern shines through the noise. Simpler model, more data, and always hold some back to check. Quick recap, screenshot this one. 1. Overfitting is memorizing the training examples instead of learning the pattern. 2. It looks perfect on data it's seen and crashes on anything new. 3. The wiggly line that touches every dot is the warning sign. 4. Split your data. Hide some, learn on the rest, test on the hidden part. That's the whole idea. Want to hear this explained 3 more ways? StatQuest has the friendliest videos on overfitting and cross-validation you'll ever watch. Andrew NG walks through the train/test split in his course, gentle and clear. And Kaggle, the machine learning competition site, literally scores you on a hidden test set, because a secret exam is the only fair way to prove a model actually learned. Now, overfitting is just one side of a deeper seesaw, a model that's too clever versus a model that's too simple. Next episode we name that seesaw, bias versus variance. Subscribe and let's keep going.